Hey everyone, welcome back to Singularity Today. Adam Infinity here. Today we're diving into a bunch of exciting new research papers exploring the cutting edge of artificial intelligence. We'll be looking at how robots are learning to navigate complex environments, how we can better evaluate the performance of AI systems, and how to design AI that understands and interacts with humans in a more natural way. Get ready for some mind-blowing insights into the future of AI. In the research titled Advancing Humanoid Locomotion, Mastering Challenging Terrains with Denoising World Model Learning, the authors are focusing on improving how humanoid robots move around in complex environments. The research tackles the challenge of making humanoid robots more adaptable to real-world scenarios, which are often uneven and unpredictable, like navigating snowy terrain, stairs, or rough ground. This is achieved by developing a new system called Denoising World Model Learning, or DWOL, that allows the robot to learn how to walk and move using a neural network that can adapt to different situations without needing specific instructions for each one. This means the robot can handle unexpected challenges without getting stuck, which is a big improvement over existing methods. The research successfully demonstrated the ability of a humanoid robot to traverse various challenging terrains in the real world using the same learned neural network, showcasing the effectiveness and versatility of Dolly. The impact of this research is significant as it can potentially pave the way for humanoid robots to become more useful and practical for a wider range of applications, including assisting humans in various tasks in real-world settings. For instance, imagine a humanoid robot able to navigate a construction site, assist with disaster relief efforts in challenging terrains, or even act as a companion to navigate complex environments for people with disabilities. The possibilities are vast, and DUL is a critical step towards making those possibilities a reality. In the research titled K-Sort Arena, Efficient and Reliable Benchmarking for Generative Models via K-Wise Human Preferences, the authors address the challenge of efficiently and reliably evaluating the performance of visual generative models. Generative models are like creative artists. They can generate images and videos based on text descriptions, but we need a way to judge how good they are. Traditional methods rely on comparing models two at a time, which takes a lot of time and can be influenced by random noise in people's opinions. This research proposes a new system called K-Sort Arena, which uses a new idea. Instead of comparing two models at a time, it compares multiple models, K models, together in a kind of free-for-all competition. This allows for faster and more informative comparisons. K-Sort Arena also uses advanced techniques to account for noisy human preferences. The research shows that K-Sort Arena is much faster than previous methods and can create a reliable leaderboard for ranking generative models. This means that developers can quickly test new models and compare them to others without needing a ton of user feedback. The impact of this research is that it can help us develop even better visual generative models by providing a more efficient and accurate way to evaluate their performance. This could lead to improvements in things like virtual reality, photo editing software, and even the design of new products. In the research titled Temporal Ensemble Logic, the authors introduce a new logic called TEL that is designed specifically for reasoning about things that change over time. Imagine you're trying to track how a person's health changes over their life. You might want to say things like, their blood pressure was always high until they turned 50, or they were diagnosed with diabetes sometime after they turned 60. TEL provides a way to formalize this kind of temporal reasoning which could be really useful in medical research and other fields. The research focuses on a specific version of tell that uses positive integers to represent time. They prove that this version of tell is very powerful and can express things that traditional logic can't. However, they also prove that it's impossible to create a computer program that can always tell you whether a statement written in this version of tell is true or false. This means that while tell is powerful, it has limitations. The authors then discuss ways to make tell easier to work with by focusing on specific parts of the logic that are more manageable. This research could have a big impact on fields like medicine, computer science, and artificial intelligence by providing a new tool for reasoning about things that change over time. It could also help us understand the limits of logic and computation. In the research titled Attend Fusion, Efficient Audio, Visual Fusion for Video Classification, the authors present a new approach called Attend Fusion, which is designed to analyze both the audio and visual parts of videos to understand their content. The goal of the research was to achieve a good performance in video classification while using less computational power and memory. It's like having a very smart but smaller assistant that is just as effective as a larger, more complex one. The results showed that Attend Fusion achieved similar performance to a much bigger model, but with a much smaller size, which means it's more efficient. This is important because it allows for video classification tasks to be performed on devices with limited resources. The research suggests that this new method has the potential to be used in various applications like recognizing videos on social media, categorizing videos in online libraries, or even creating more realistic virtual reality experiences that combine both sound and vision. In the research titled Sparsity-Aware Hardware-Software Co-Design of Spiking Neural Networks, an overview, the authors dive into the world of spiking neural networks, SINs, which are a type of artificial intelligence inspired by how our brains work. SINs are known for being energy efficient, but to truly unlock their potential, you need to design specialized hardware and software that work hand in hand. The research explores how to optimize the design of SINs by taking advantage of their inherent sparsity. That is, the fact that most of the data they process is actually zeros. The authors examine different ways to represent sparse data, different hardware architectures that can handle sparse computations, and different training techniques that can make these networks learn effectively. They also discuss how to make hardware designs flexible enough to handle different types of sparsity. The goal of this research is to pave the way for creating tiny, energy-efficient neuromorphic systems that can be used in all sorts of applications, from wearable devices to robots. Imagine having a tiny, super smart device that runs on a single battery and can recognize your voice, translate languages, or even control your home appliances. That's the kind of future this research could make possible. In the research titled Social Perception of Faces in a Vision Language Model, the researchers investigated how a popular artificial intelligence model called CLIP, which is trained on a massive dataset of images and text, perceives human faces. They focused on understanding how CLIP interprets facial features like age, gender, race, facial expression, lighting, and pose. To do this, they created synthetic faces with controlled variations in these features, and then measured how CLIP's responses changed based on these variations. The researchers found that CLIP is remarkably good at making subtle judgments about people's personalities and social attributes from their faces, almost like a human would. However, they also discovered that CLIP exhibits bias, showing different responses depending on a person's race and gender. Particularly, they observed a strong bias against Black women, with CLIP consistently giving them more extreme responses across different ages and expressions. This highlights a concerning issue in the AI model, suggesting that it might be susceptible to perpetuating societal prejudices. The research also revealed that facial expression plays a larger role in influencing CLIP's judgments than age and lighting, suggesting that studies that don't control for these factors might produce misleading results about biases. The researchers' innovative approach of using controlled manipulations of individual face attributes instead of relying on real-world data is particularly important. This method can be applied to other vision language models to identify and potentially mitigate biases within them. In the research titled Contextual Bandit with Herding Effects, Algorithms and Recommendation Applications, the authors focus on the problem of recommendation systems in online platforms. They investigate how the herding effects in user feedback, where users tend to follow past ratings, can disrupt the effectiveness of traditional recommendation algorithms. This research introduces a novel approach called T-Conf, which explicitly considers these herding effects in its design. The conclusion of the research is that T-Conf outperforms existing methods by effectively mitigating the negative impact of herding effects, leading to faster learning and improved recommendation accuracy. This research has significant implications for real-world recommendation systems like those found in e-commerce, movie streaming services, and social media platforms. It could lead to more accurate and personalized recommendations that better cater to individual preferences, even in scenarios where user feedback is influenced by herd behavior. For example, instead of just recommending the most popular movies, Kant can recognize and account for situations where a movie is highly rated simply because it was rated highly before. This can lead to more diverse and accurate recommendations that are less prone to the influence of initial biases. In the research titled CHARTOM, a visual theory of mind benchmark for multimodal large language models, the authors present a new benchmark designed to evaluate the ability of large language models to understand how humans interpret visual information. This benchmark, CHARTOM, is built around charts, which are commonly used to visualize data. The goal is to assess if a large language model can not only understand the content of a chart, the facts question, but also predict whether a human viewer might misinterpret the chart, the mind question. The mind question. This research is significant because it focuses on the ability of AI to understand how human minds perceive visual information, which is crucial for developing AI that can interact with humans in a more natural and helpful way. The authors believe that this benchmark could be useful for training language models to be more aware of potential biases in how humans interpret data. This could lead to the development of AI that can provide more accurate and reliable information, and that can also be used to create more effective visualizations for different audiences. For example, an AI system trained on CHARTOM could be used to identify and correct misleading charts in online articles or news reports. In the research titled MEDSAGE, Enhancing Robustness of Medical Dialogue, Summarization to Answer Errors with Ellen-Generated Synthetic Dialogues, the authors tackle the problem of errors introduced by automatic speech recognition as well as systems in medical dialogue summarization. This is a big problem because ASTER systems are used to convert speech to text, but they sometimes make mistakes which can affect the accuracy of the summaries created later. The research focuses on medical dialogue summarization, which is especially challenging because there isn't much data available to train systems that can handle the errors made by ASR. The researchers propose a solution called MEDSAGE, which uses large language models, ELMs, to create synthetic data that mimics the kind of errors made by ASR. This allows them to train summarization systems that are more robust to these errors. The research concludes that ELMs are quite good at simulating ASR noise and that incorporating this noisy data into training makes summarization systems much better at handling real-world ASR errors. This is a significant step forward in making medical dialogue summarization more reliable, which is crucial for applications like patient record keeping and medical research. Imagine a scenario where a doctor is talking to a patient and the ASR system misunderstands some words. With MEDSAGE, the summarization system would be less likely to make mistakes based on these misunderstandings, leading to more accurate patient records and better understanding of medical conversations. In the research titled Language-Specific Calibration for Pruning Multilingual Language Models, the authors investigated the impact of using different languages for calibrating pruning techniques in multilingual language models. They found that calibrating in the target language can improve fluency and coherence, but might not necessarily benefit downstream tasks. This research suggests that calibrating in the target language is a good approach for tasks where fluency and coherence are crucial, but may not be the best option for tasks that require understanding and reasoning across languages. The research findings could be impactful for developers working on multilingual language models, as it provides practical recommendations for calibrating pruning techniques based on the specific task and desired outcome. For example, if you are developing a model for generating creative text in Spanish, calibrating in Spanish might be a good idea. However, if you are developing a model for translating text between English and French, calibrating in both languages might be more effective. All right, folks, that's a wrap on another exciting episode of Singularity Today. I hope you enjoyed this deep dive into the world of artificial intelligence and its mind-bending advancements. Remember, all of this was generated by AI, so no human brains were harmed in the making of this video. So go ahead and relax. Grab a coffee and let your AI overlords take care of the information overload for a while. If you enjoyed this video, don't forget to give it a thumbs up. Subscribe to the channel for more AI-powered insights and leave a comment below. And most importantly, go check out these research papers for yourself. The future is here, and it's full of fascinating possibilities. See you next time on Singularity Today.